is the first experiment, right? So I want to talk about, we're back on functions. We're still on this study guide and intervention page. 1-1, study guide and intervention. I don't know if I gave this to you yet. Okay, still on page 5, right? I want to go back over it, and then we're going to talk about what is called set builder notation. Right? Okay, so we have real numbers. Real numbers, they are designated with big R. That's everything, right? It's everything we talk about in this class. Okay? All the numbers that we talk about in this class are real numbers. We move on then to rationals. You guys remember the definition of a rational number?
Rational? Hold on, wait. What happened?
Anything that's a fraction?
Anything that can be written as a fraction, A over B, where B, the denominator, can't be 0, right? That doesn't exist. Then we move on to irrational. And we go with,
Imaginary.
wrong side.
No.
No.
We started-
Yeah!
We started this like.
Yeah, I know. Just go back over it real quick.
Yeah.
Because I want to put the letters on there. Non-terminating, non-repeating decimals like pi. Okay? Square root of 2. Excellent. Then we go on to integers. And we give that the letter Z. Okay? Cool? Integers. Positive and negative whole numbers. Yeah? Cool? All right. Where'd it go?
I lost mine too.
Oh, that's the way it goes, man. I'm not making more just because you felt like losing it. How am I supposed to do this?
I don't think I got it.
Oh, you got it because I gave it out on the first day of class.
It was actually the third.
You want to fight?
No.
There's the door. All right, I will stop everything to make extra copies. Right? Because apparently that's what we have to do.
If you want to, son. No, it's okay.
Huh? You got to have it, or else we can't do this.
What's you laughing about, Rips? Something funny?
Put it inside your
Yes.
notebook.
Be quiet, bitch.
Oh.
Hey,
Whoa!
what did I just say?
I'm
Oh,
for
live?
I was recording.
Oh, mine?
I don't know who you talking to, sir.
4K.
Fools.
4K straight.
Which one, sir?
She gonna try every that up now.
Straight to the EO rap.
Sure, you know what you should do? If we curse, you gotta give detention.
No. I'll do 10 push-ups like Siki.
515.
Oh,
Straight doesn't work anymore.
Oh, it does.
I bring it back towards
What? Okay.
All right, let's go.
you.
Sir.
After integers.
Sir, which one was it?
Study guide, right now.
Oh.
We got holes. Easy enough. I can have remember to change markers. And then we have naturals.
What's a hole, sir?
Whole number. Counting numbers starting with 0. Natural numbers, counting numbers
Starting with 1.
starting with 1.
Good job, Thomas.
Thank you, best.
Hey, you know. A weird way to say it, Mr. Thomas, but it is what it is. Good? All right, here we go. Who's scared? Something new. You're scared? Are you really scared?
Yeah.
So, if I have something that looks like x is greater than and equal to 3, right? What types of numbers am I talking about?
Real.
Real. I'm talking about everything greater than, including 3. Everything to the right of it.
So are
Right.
we able to throw the AC?
Say it again.
Are we able to throw the AC?
Turn off the AC.
No, sir.
No, it's gonna get real hot, real
You
fast.
said move your seat. You said right in front of me.
But I'll make it warmer.
Thank
Holy
you.
crap, that didn't work.
It was freezing.
It's gotta be.
Yes, bro. Ever since I woke up.
Yeah, it's because you're right in front of the AC.
That AC blow hot.
I appreciate the fact that you have your glasses, by the way.
Thank you.
Thank you for doing that. So we're talking about reals. If I have a situation where I have a set of numbers, let's say -3,
Integers.
-2, 1, ellipses. Just like Thomas said, these are integers, right? Great.
Good job, Mr. Thomas.
Thank you, Master.
Wait, what did you call me?
Thank you, Master.
Oh,
Sir.
X is less than 4 6/10. Okay? That 4 6/10 tells me something.
Rational.
right, yeah.
Rational.
We're going to go with the rationals, right? This 4 6/10 tells me something. It's going to tell me I'm looking at rationals. Could it be argued? Oh.
It's not rational?
Could it be argued that it's real? Yeah, it's rational.
No, it could be both.
Yeah.
Could be both. It could be argued that this is subjective. We're talking about everything less than 4 6/10. So I'm not going to put you in a situation where it's subjective. If I ever do put you in a situation where there's more than one answer and you can argue your case, or a case can be argued by somebody else, you'll get credit for both. All right? I'm not going to put you in a situation where I say one thing and that's the only thing that's possible. It's not true. Sometimes it's subjective, which means it's up to you. Right? So that's the easy part, right? Well, we do this so that we can write this set out in what is called set builder notation. Set builder notation is probably the most annoying thing you'll ever learn. And I'm going to take that first example, and I'm going to write it in set builder notation.
Sure, we got tests and quizzes in this class too, right?
Yeah,
Okay.
we are going to have a quiz on Friday.
What? Better start studying.
It'll just be the first couple of sections. We'll have a quiz on Friday.
I don't understand the words that's
So it looks weird, right? Looks like a bunch of gobbledygook. I don't disagree.
Real.
This is you learning math as a different language. And I know that I have said this, because it's in someone's notes. It's in Yao's notes, right? But here's the translation. That's why he's not writing it again. All numbers x such that x is greater than and equal to 3. And is an element. You already have this written down, Yao. I just used a different example of
So I don't have to rewrite
all.
it again.
If you have it written down already, don't worry about it. All real numbers.
Oh, yeah.
It could be the set of all real numbers, but this gives you a look, right?
Is there
So
a difference between
all
set-
numbers x, that's where that beginning x is, right? Such that, that's that vertical line. Well, x is greater than and equal to 3. You see that, right? You see that x is greater than and equal to 3. And is an element of, that's that weird looking E right there. And then there's the R for all real numbers, right?
I got a question.
Yes,
Is set builder notation different than set point notation?
yes.
That's what I have written down.
What's that point notation?
I don't know.
What?
Never heard of it.
You mean about,
Talking about a point? No, it's probably on his computer.
No, it's what I wrote down.
I don't even know.
This is your notes.
I don't even know. how
I
to
never
do
said
it.
set point notation, so I don't know. I don't know what you're talking about.
when you write that down?
Set builder
You wrote it.
notation.
I wrote
what
this.
he
I
wrote.
wrote this down. But I didn't
Set
write
builder
notes.
notation.
Set builder notation.
I remember you wrote notes.
Just accept
Okay.
it, bro.
Alright.
Writing gibberish.
It's all right.
Everybody makes mistakes.
You already wrote this down. I don't know why you're writing it down again, but that's okay.
I'm gonna write it down again.
You wrote it down, right? Yeah, you wrote the translation. All right, so you're going to help me out so we can move on. I'll move on to the other side as quickly as possible. So you can do your homework.
Hey, you're not glass.
It's not right.
Let me know when you're ready. Now, does everybody have practice 1, or do I have to get that out again too? Oh, no, there's a line. Oh, I got you blocked out. And once you break it. No, the line. It's so sad. Oh, thank you. Say that again. Are we good? Great. Ba-da-ba-ba. So, all step builder notation starts with the brace. You have an X. All values of X. You'll have your vertical line. You'll have some sort of inequality. And then you'll have a comma, the element symbol, and what set it belongs to. Okay? Those are always going to be there. And the reason we're doing this is because we have to be able to list domains and ranges of functions. That's where we're headed. Okay? What we see, we're analyzing functions. That's what we're doing right now. So let's take this second example. What kind of inequality could I show for this set? It's going positive, right? So it's everything greater than
-4.
-3. All right, so I could say x is greater than -4, or, oh no, here's subjective, right? X is greater than and equal to -3. Are these two things the same if we're only talking about integers? Yeah. Yeah. But are these two things the same if we're talking about real numbers? No. No, because there's some space between -4 and -3 that could get accounted for, right? -3.5. Right? Okay. So how do we show that these two things could be the same? We use set builder notation. So how do I start? A brace. What comes next? What do I write next? What else? Vertical line such that.
X.
Now, I'm going to use both.
X is greater than.
And what do we call it? We said they were
Integers.
integers. So I'm going to put a z here.
So the E is just there.
So it's an element of integers. It's an element of the set of integers, right? So this is true. Or I could write it using this inequality.
So for number one, I do.
I'm not there yet, but yes, that's where I'm headed. How did you know? How dare you? Good job. Good job. Good? We got it?
Oh, yeah.
Almost. These two things are exactly the same now.
I'm doing it myself.
Right? Okay, we're going to move to number 1 on the sheet. Give me a chance to erase. Right here in the middle. Number 1 has a set that looks like this. I know you can see it, but I'm going to write it just in case. 17, 18, 19, 20, ellipses. Right? First of all, what types of numbers are these?
Real.
Okay, real. What else?
Integer.
Rational. Right? You can express every one of those as a fraction, right?
Mhm.
Are they whole numbers?
Yes.
Are they integers?
Yes.
Are they natural numbers?
Yes.
Yes. Which one of these is the most specific, which is the narrowest set that I can use for this? Naturals is the most, what I call uber specific set. The truly most specific set. So I'm going to say that these are naturals. And now what might my inequality look like if I'm talking about natural numbers? Give me an inequality. First, give me an inequality. We're talking about every number Every number that's greater or less. Are we going up or are we going down?
We're going greater.
Good job, Hurst. You did a great job. Hurst, do we want to include 17 or talk about 16? Let's include 17. Great. There's our inequality. Now, write that in set builder notation. You have a couple of examples here. Go. Did you already write that one? Write it in set builder notation. Write it like this.
Yes, Lord.
Use this here. Use the right designation. Okay? We know it starts like this.
On a paper.
We know it's like this.
No.
You can. You can. What comes next? The inequality.
So why do we use set builder notation? What does it do?
It tells us the set of numbers we're looking at. So when I'm looking at a function, when I'm looking at the graph of a function, I can talk about the domain of the function, all the x's that are included with it, and all the y's that are included in that function. That's what's going to help us in our next step.
That's gonna help us on the quiz.
You betcha.
Hmm.
You
I
betcha.
didn't write a line because the -4 didn't have a line under the greater. So-
Right, but how else can I write this to include all these numbers if I don't want to include the equal sign?
I just-
Look at the difference between these two things, right? I included the 3 because the 3 was part of it, right? But if I used, if someone had said
16.
everything greater than 16, yes,
You don't need a line.
we don't need it, right? And we said we're talking about natural numbers.
So
Well,
why do you use
What's
line?
greater than, if I want to include the number I see in the set, I use the equal, that half equal sign there. If I don't, I go down one number or up one number and start there. But it only happens when we're talking about integers, naturals, and wholes.
It's like,
That's the only time the line pops up.
Yeah.
Uh,
That's the only time we have a choice,
Integers is
oh,
okay?
Why is that?
Integers, wholes, and naturals, because they're so specific. When we're talking about counting numbers or whole numbers that are positive or negative, we're not talking about spaces in between.
That's the second thing I learned.
That's good. We're supposed to learn it here. I'm almost done.
actually.
Or, now, if you're given, like, every single one of these, you could do every single one of these on the bottom,
On this page.
on page 5. Because you would write this, figure out what their most specific set is, and then just input this.
Okay, question.
Input
So
your,
what's interval notation?
No, what is the EN for? Or the EZ? So that's like,
So, look, you see all those like
Right
red
here.
letters? E stands for elements. You just write element. You always have to write element. But you gotta choose one.
the element. Okay. Thanks.
So what numbers are we doing?
So next, wait. So
Everything on the bottom.
for number 16, say number 16, number 6, I would just like pick a number like what we did for number 1
Yeah.
and do it like that.
Yeah.
Which one are you talking about?
Number 6.
Number 6. Yeah, number 6 is very much like this.
Okay, so
Only it goes the other way, right?
I just chose a number.
And we're talking about integers, right? Because they're negatives,
Uh,
and it just steps down by negative whole numbers.
What is happening with number 4?
Awesome, great question. Let's talk about number 4. We're talking about every number between 5 and 15, right? No equal signs, every number in between 5 and 15. So all of those numbers in between, all real numbers in between them. So if we have something that looks like this, if I wanted to see it on a number line, I'd have open circles around 5 and 15 and shade everything in between, right? Well, I don't want a number line. I want set builder notation. Well, I know that everything in between is real numbers. There are some rationals in there. There's some irrationals in there, right? What's square root of 26? Irrational. Make sense? Cool. So there are rationals and irrationals and wholes in there and
So we gotta
naturals.
pick which one's the
So all these things in from here to here, they're inside there as well as that and that. They're all in there. So we're talking about real numbers now. So I'm going to, instead of the same thing, right? I put my 5 is less than x, which is less than 15. And now I'm just going to call it the element of real numbers. Is that all right?
I can.
So all I've done really is found out what types of numbers are within this inequality. I've labeled it, and I've just replaced that inequality.
Sure, I have a question though.
Go ahead.
It's not really a question, it's just, I want to check on my answer. For number 2.
What are we looking at in number 2? What types of numbers are we looking at? Everything that's less than or equal to -2?
Yeah.
What types of numbers am I looking at?
Integers.
Well, there are integers in there,
Uh-huh.
but what about everything else? It's talking about everything.
Real.
Yeah, I would go with real. It doesn't have a list like this that makes it so specific. So if you have a simple inequality,
So I got number
everybody
2.
got this? Everybody got this one? I can get rid of it? We got this one for sure.
Wait, so what's interval notation?
It's using those same braces, those brackets,
It's like, can I use
to show
interval
that it goes
notation
on.
for number 2?
Well, we do.
We do.
We just did.
That's interval
That's
notation?
what these guys, well, okay, interval notation is using this to show a bunch of numbers,
Okay.
right? That goes on infinitely. So I wouldn't use interval notation for number 4, but I could use interval notation for 2, 3, and 6. As well as 5. Everything greater than 1. Yeah. I could if I wanted to show it. But And we're going to use interval notation when we start talking about domains. Interval notation is used when there's an infinite side or sides. That's what it says on the paper, right?
Is this our one?
Yes.
No,
Oh,
but thanks for answering. Where was I? That's the one we were on, right?
Yeah.
And Mr. Calix decided these were real numbers after we discussed it, right? Good?
Yeah.
That's it, baby.
What number is this?
Alright, so number 5.
For number 5, yeah.
I pick the right
We have an or.
since
Why
the
can't you
CP.
bring, wait, sorry to interrupt you.
It's both, right?
Why can't, so do you supposed to do both?
Yeah.
Well, you have.
And you're gonna put the or in between. When you write it up in here, you're gonna put the or in between.
Okay, go ahead, Tom.
Because it's everything, right? If I wanted to write this in interval notation, right?
Yeah.
Well, how about I just graph it instead? Let's talk about, what is it, -11?
Because it says -11 is greater, that means it's going up.
Or
It's going to the right.
Or
of
when?
-11.
No. It says x is less than -11.
Yeah.
And it says x is greater than and equal to 1. That's what it looks like. These are the numbers we're looking at. Now, when I have this arrow going this way and this way, am I only including whole numbers?
no,
Am I only including integers?
no.
Am I only including the rational numbers? I'm including everything on that line. So we're talking about reals. Hey. Language.
I'm sorry. I see it back at paper.
Well, taking your time.
What's the bad one? The example's right there. You tripping.
And we decided we were talking about all the real numbers that are on that number line.
Mhm.
Are we gonna get tested on this?
Yes.
Yeah. All right, since we've taken a long time. How many people don't have this paper?
Which one is that one?
Practice.
Oh, I have that one.
Who doesn't have the practice paper besides Martelli?
Sir.
Tyler. Get it.
Monsieur.
Hey, monkey, hey.
No. You need this, right? Homework?
No, what is that?
Yes. Tyler, did you ever get waterboarded in the army?
He's not in the Army.
You know what?
How could he get waterboarded? That's a weird question.
I'm just saying that. I was just talking.
Right?
I can see anywhere though, I'll tell you that.
Martelli, isn't that a weird question?
Very good question.
Like out of nowhere.
No clue what you're talking about.
Here's your homework. It's not time yet.
Oh, there's a time?
Don't you have that next?
Calc?
Yeah.
No.
When?
CP5?
5? All right. Can you give me a second to tell them what their homework is, and I'll be right there?
Mr. Todd.
All right. Your homework is 1 through 8. I lied. 1 through 9.
How am I supposed to know the difference?
Well, we already went through this.
You did?
If it's a function, we can use the vertical line test, right? If you go back in your notes, the vertical line test says I can draw a vertical line anywhere on this function, and it only touches the function once. It only intersects once, right? So if you're looking at number 6, can you draw a vertical line through it and touch it more than once?
Yes.
Does it intersect more than once? Where? Vertical.
Oh, no.
So if it doesn't intersect more than once, then it is a function. That's a sine wave, by the way. A negative sine wave. Yes.
Somewhere around there, there's one, like about 10, after I get to the work.
What did you do with the papers, young man?
So Cardi, you know how we walk around.
I don't know what exactly do with this.
Nobody around.
I got you, Chris. I promise.
Therefore,
That's fine.
Mr. Cargill, you said this was a function because you couldn't intersect it more than once. Is this next one, can you draw a vertical line through it and touch it more than once?
No, it's gonna touch twice.
Twice. That
Yes.
means it's not a function. So you can just fix that right now and say yes and no, and you're good to go, right?
Oh, I do have the paper.
Oh, where were you? You guys gotta get out.
Oh.
You're late. You're late.
What?
We don't have,
Sir.
Hurry up.
It's at 11:15.
we don't have class until 11:15.
11:15
No, no,
today.
no. No. That's not-
Oh.